Good morning, students. Today we are going to discuss two very important topic, Torricelli's law and Venturi meter. Basically, these two topic uses the theorem Bernoulli's theorem as well as equation of continuity. Now, how can we use that two topics that we had discussed in previous class? One is your equation of continuity, another one is your Bernoulli's theorem in these two experimental setup. That part we are going to discuss today. Now, this is your Torricelli's law. Now, what is Torricelli's law? We'll come across afterwards. Now, you see this figure. It is a container, and the top surface is closed, and on the right side there is a very narrow hole, and the container contains certain amount of liquid, and the height of the liquid from the base of the container is your h, and the height of that narrow hole from the base of the container is your x. So if you measure the height of the liquid from the narrow opening or narrow hole, that is nothing but is your h minus x. Now you see you do have two area of cross section, and one is your top surface of the container with area of cross section a1, another one is your area of cross section of the narrow hole, which is on the right side of the container wall. Now there is a pressure P1 inside the container at the free surface of the liquid, and another one is your pressure P2, which is nothing but is your outside pressure, or you can say the pressure of the liquid with which it moves with the velocity v2, and v1 is the velocity of the top surface, free surface of the liquid, you can say, by which it is getting down as the liquid is coming out through the narrow opening of area of cross section A2. Now, if you have to apply Bernoulli's theorem on the two area of cross section, one is your A1, another one is your A2, and the parameters are A1, P1, V1, and another one is your A2, P2, V2. So, if you see the Bernoulli's theorem in our previous class, you will see that theorem define the conservation of energy, and the conservation of energy is your pressure energy, potential energy, and kinetic energy. So if you are going to apply that theorem in two different area of cross section, then the equation will be P1 by rho, where rho is the density of the liquid, GH, because the free surface is at a height h from the base of the container, and V1 square by 2, that is your kinetic energy. And on the area of cross section A2, you do have P2 by rho plus GX, x is the height of the narrow opening from the base of the container, and V2 square by 2. So this is your Bernoulli's equation. We have applied in two different area of cross section, A1 and A2. Now let me try to apply equation of continuity in two different area of cross section. One is your A1 V1 equal to A2 V2. So V1, if you simplify, V1 equal to A2 by A1 into V2. Now A2 is very less, or A2 is very less, not greater. It's an error, please check it out. This part should be very less, is not it. You see, A2 is the area of cross section, so A2 is very less than A1, so be careful. So if A2 is very less than A1, then V1 approaching towards 0, you can consider. It means the velocity with which the liquid free surface getting down, you can neglect the velocity. It is almost tends towards 0. That's your V1, because A2 by A1 is very less, and under that condition you can consider V1 approximate towards 0. Now if you apply this equation 3 in equation 1, you will see that P1 by rho plus GH equal to P2 by rho plus GX plus V2 square by 2, because V1 is your 0. Now if we consider that both the opening, narrow opening, and the free surface of the liquid which you have closed for the time being, if you keep it towards atmospheric pressure, then P1 equal to P2 if you open the top of the container, because the narrow hole is in with the atmospheric pressure. So if we make the free surface with the pressure of atmosphere, then P1 equal to P2. So under this condition, you will see that P1 by rho and P2 by rho goes off. So you do have GH equal to GX, B2 square by 2. So G H minus X. So H minus X is nothing but the height of the narrow opening from the free surface. So if you see this one, G H minus X equal to V2 square by 2. So V2 square equal to 2G H minus X. So if you consider H minus X is your S, then it becomes is your V square, V2 square equal to 2G H minus X, or V2 square equal to 2GS, or you can say V2 equal to root over 2GS. Now this equation has a similar equation you do have in free fall, using the equation V square equal to E square plus 2AS or 2GS, whatever you say. So this equation has similarity. It means the liquid, that is V2 is the velocity of the liquid with which it is coming out from the narrow opening A2. It means the velocity with which the liquid coming out from the narrow opening can be defined by the equation of the free fall. That is your that is nothing but the height of the narrow opening from the free surface of the liquid. That is your H minus X. So V2 equal to root over 2GS. So this equation has a similar equation with the equation of free fall. So this is your Torricelli's law. Torricelli's law states that the liquid which is coming out from the narrow opening can be defined by the equation of free fall, or you can say equation of motion, that is your V square equal to E square plus 2AS. So that is your Torricelli's law. It means if you take an object at higher level and if you let it to free fall, so what will happen? It moves with high velocity. So similarly here is also happening. If the height of the liquid surface is very high, then velocity is also high. But as the time progresses, as height is decreasing with the liquid that comes out from the narrow opening, it means the liquid that comes out from the area of cross section A2 comes closer to the container with the passage of time. So please go through and try to find out your doubts. It's a very interesting one if you study. If you don't study, it seems to be very tough. Now it's on you. Now next topic is your Venturi meter. You see again you do have a container of different area of cross section. No, this is your wider area of cross section A1, and another one is a small area of cross section area A2. Now you see basically this part is your open. This part is your open. Otherwise liquid will not comes out. You see the U tube is connected. U-shaped tube is connected. Now no liquid is coming out or no liquid is mixes with the liquid which is available in the U-shaped tube, because the liquid flows with very high velocity. So you can neglect the liquid that, or you can say the area of cross section of the U tube is very less. So you can neglect the drop of the liquid that moves through the variable area of cross section. Now you see we have considered two different points with different area of cross section. One is your A1 and another one is A2, and the parameters are P1 V1, another parameter is P2 V2. So P1 is your pressure, V1 is the velocity. Now we are going to apply Bernoulli's theorem here again. So as two area is of you can say the common center of point, you can say concentric, you can say two circle which you have drawn at considering area of cross section A1 and A2, they have a common center. So if it has a common center, it means you can neglect the potential energy, because whatever level you will consider, the height remains same in both cases. So that's why that two terms goes off. So you have not written here. So here are two terms we have written. One is the pressure energy, another one is the kinetic energy. So pressure energy P1 by rho V1 square by 2 equal to P2 by rho V2 square by 2. Now from equation of continuity, again A1 V1 equal to A2 V2. So V1 equal to A2 by A1 V2. Now using 2 in 1, what we will do, we will replace V1 with this A2 by A1 V2. So A2 by A1 whole square, V2 square by 2. So V2 square term by 2 will take one side, V2 square by 2, 1 minus A2 square by A1 square, and this side P1 minus P2 by rho. So P1 minus P2, V2 square by 2, 1 minus A2 square by A1 square, bracket closed with rho. Now you see here already we have defined pressure remains same on the same level. So if you consider U-shaped tube, AB and A dash B dash is of the same level. That's why pressure at AB will be same as pressure at A dash B dash. That part we have used it here. Here PAB equal to PA dash B dash. Now you see PAB, pressure at AB is nothing but the pressure corresponds to P1, is not it? Pressure exerted by the liquid which moves through the area of section A1. So here PAB we can replace with P1. Now with PA dash B dash, you see here you do have a pressure P2 and simultaneously there is a pressure of the height of the mercury column of a height h, small h. So at A dash B dash you do have two pressure, one is your pressure P2, another one is your pressure exerted by the height of the mercury column h. So you can say that PAB equal to P1 equal to P2 plus H rho mg. Rho m is nothing but the density of the mercury. So you do have two liquid, one is your density rho, another one is your density rho suffix m. Rho is the general density for the general liquid and rho m is the density of the mercury. So P1 minus P2 equal to H rho m g. Now what we'll do, we'll use 3 and 4 and we'll try to find out V2. So P1 minus P2 you can write H rho m g, and you can simplify by multiplying 2h rho mg by 1 minus A2 square by A1 square within bracket close rho. So V2 comes out to be your 2h rho mg 1 minus A2 square by A1 square rho to the power half. So you see velocity with which the liquid is moving can be defined by this parameter, and this is very simple parameter. Area of cross section is known from the apparatus. H is unobservable. Rho m is the density of the mercury, it's a common constant. Rho is the density of the liquid, is constant. So if you know this parameter, you can define the velocity of the liquid with which it comes out through the area of cross section A2. Similarly, you can define V1 by using this equation. So we have written similarly V1 can also be defined from equation 1, 2 and 4. So 1 is your this one, 2 is your this one, and 4 is your this one. So you can define V1 and V2 provided you know this parameter. So this two topic is nothing but the application of the Bernoulli's theorem and equation of continuity. If you understand, it's very easy. If you study, then definitely you will understand. If you don't study, it seems to be very tough. So it's up to you which one you want to choose. So thank you. Check it out.